What happens when you drop a high-performance V8 into a vehicle designed to haul hay bales and lumber? In 1967, you got pickup trucks that could embarrass Jaguar E-Types at stoplights. This is the story of how Chevrolet's 327 cubic inch small block turned working vehicles into accidental performance machines that left European grand tourers wondering what just passed them. Picture this. It's 1968, and you're cruising down Route 66 in your imported European coupe. Maybe it's a Triumph TR6, or if you're particularly well-heeled, a Jaguar XKE. You pull up to a stoplight next to what looks like a farmer's Chevy C10 pickup. The light turns green. That truck disappears into the horizon while you're still rowing through second gear. What you just experienced was America's best-kept performance secret, the 327-powered pickup truck. The Chevrolet 327 small block V8 wasn't just another engine option. It was 5.4 liters of Detroit iron that fundamentally changed what a utility vehicle could be. Between 1962 and 1969, this engine turned ordinary pickups into something the automotive world had never seen before: work trucks that could run with sports cars. To understand how revolutionary this was, we need to travel back to the early 1960s. The pickup truck market was purely utilitarian. Ford offered their F-Series with inline sixes and modest V8s. Dodge had their D-Series with similar options. International Harvester built trucks like agricultural equipment, sturdy, slow, and about as exciting as watching paint dry. The idea of performance in a pickup was like expecting speed from a tractor. Meanwhile, in Europe, the sports car renaissance was in full swing. The Jaguar E-Type had just debuted with its 3.8-liter inline-six, making 265 horsepower. Porsche was refining the 911 with its 2.0-liter flat-six, producing 130 horsepower. The Alfa Romeo Giulia Sprint GT offered 106 horsepower from its twin-cam four-cylinder. These were considered the pinnacle of performance engineering: sophisticated, complex, and expensive. Enter General Motors' small block V8 program. The 327 started life in 1962 as a bored and stroked version of the 283. The bore measured 4.0 inches, the stroke 3.25 inches, giving exactly 327/30 cubic inches of displacement. But here's where it gets interesting. This wasn't some agricultural lump designed for torque at 2,000 RPM. The 327 featured a forged steel crankshaft, high silicon aluminum pistons, and in its highest specification, solid lifters and an 11.25:1 compression ratio. The brilliance of the 327 wasn't just its power, it was its versatility. Chevrolet offered this engine in multiple configurations. The base L30 version with a two-barrel carburetor produced 250 horsepower at 4,400 RPM and 350 lb-ft of torque at 2,800 RPM. Already, that torque figure exceeded what most European sports cars could muster. The four-barrel L74 pushed out 300 horsepower. But the real monster was the L76, the 365 horsepower variant with fuel injection that could spin to 6,200 RPM. Now, here's the kicker. Chevrolet's marketing department decided to offer the 327 as an option in their CK pickup line starting in 1967. Not the fire-breathing L76, but the L30 and L74 versions were available for anyone who checked the right box on the order form. The option code was L30, and it cost an additional $142.15. That's about $200 in today's money, less than what most people spend on aftermarket wheels. The transformation was immediate and shocking. A 1967 Chevrolet C10 fleet-side with the standard 250 cubic inch inline-six weighed approximately 3,400 pounds and made 155 horsepower. That gave a power-to-weight ratio of 21.9 pounds per horsepower. Respectable for a work vehicle, but nothing special. Drop in the 300 horsepower 327 L74, and suddenly you had 11.3 pounds per horsepower. Let me put that in perspective. A 1967 Jaguar E-Type Series 1.5 with its 4.2-liter engine made 265 horsepower and weighed 2,900 pounds. That's 10.9 pounds per horsepower. The Chevy truck was virtually identical in power-to-weight ratio to one of Britain's most celebrated sports cars, except the truck cost $2,700 fully equipped, while the Jaguar started at $5,500. But raw numbers don't tell the whole story. The 327's torque curve was what really made these trucks special. Peak torque of 350 lb-ft arrived at just 2,800 rpm. In the lightweight short-bed C10, which tipped the scales at barely 3,200 pounds empty, this meant instant, crushing acceleration from any speed. The standard 3.7-3.1 rear axle ratio multiplied this torque at the wheels. In first gear, the mechanical advantage was so extreme that wheel spin was the limiting factor, not power. Contemporary road tests tell the story. Hot Rod Magazine tested a 1968 C10 stepside with the 327 and a 4-speed manual transmission. 0 to 60 took 7.2 seconds. The quarter-mile fell in 15.3 seconds at 89 miles per hour. For comparison, a 1968 Porsche 911T needed 8.5 seconds to reach 60 and ran the quarter in 16.1 seconds. A Mercedes-Benz 280 SL, 9.3 seconds to 60. The truck was literally faster. But here's where it gets really interesting. The 327-powered pickups had a secret weapon on the highway, gearing that amplified their already impressive torque. Unlike European sports cars with their close-ratio transmissions designed for mountain passes, the truck's wide-ratio 4-speed was optimized for pulling power. Third gear was essentially an overdrive, perfect for high-speed cruising. Combined with the tall final drive, these trucks could cruise at 80 miles per hour with the engine barely turning 2,800 RPM, right at the torque peak. This meant passing power that defied logic. From 50 to 70 miles per hour, a 327 C10 needed just 4.1 seconds. A contemporary BMW 2002, 6.8 seconds. The Triumph TR6, 7.2 seconds. Even the vaunted Alfa Romeo GTV was slower, needing 5.9 seconds for the same passing maneuver. American truck drivers were experiencing acceleration that European sports car owners could only dream about. The 327's architecture was deceptively simple compared to European engines. Single overhead valves operated by push rods and a single camshaft. A simple 4-barrel carburetor instead of complex fuel injection or multiple carburetors. Cast iron block and heads instead of expensive aluminum. No overhead cams, no complicated valve timing, no exotic materials. Yet it made more power per liter than many European designs while running on regular fuel. The combustion chambers told the real story. Chevrolet engineers had spent years perfecting what they called wedge combustion chambers. The design promoted excellent flame propagation and allowed for high compression without detonation. The valve sizes were massive, 1.94-inch intakes and 1.50-inch exhausts on the standard heads. The high-performance versions got 2.02-inch intake valves. These were bigger than what Jaguar used on their race-bred XK engine. The rotating assembly was overbuilt by European standards. The forged steel crankshaft was designed to handle 500 horsepower, even though the production engines made far less. The connecting rods were forged steel, shot-peened for strength. The pistons used a special aluminum alloy with 12% silicon content for thermal stability. This wasn't just reliability, it was the foundation for unprecedented longevity under hard use. And these engines were used hard. Unlike pampered European sports cars that saw occasional weekend drives, 327-powered trucks worked for a living. They hauled cattle trailers up mountain grades. They pulled boats to lakes. They carried construction materials all week, then went drag racing on Saturday night. The engines just kept running. The torture test came from an unexpected source, law enforcement. Several state police agencies ordered special high-performance pursuit vehicles based on the C-10 platform with the 327. The California Highway Patrol's evaluation was particularly brutal. They ran a 327-equipped C-10 at wide-open throttle for 1 hour straight on their test track. Oil temperature hit 280 degrees Fahrenheit. Coolant temperature peaked at 235 degrees. The engine never missed a beat. After cooling down, compression was still within factory specifications on all 8 cylinders. Try that with a highly strung European engine of the period. The Alfa Romeo's twin-cam 4 would have scattered itself across the track. The Jaguar's inline-6 would have cooked its bearings. Even the Porsche flat-6, renowned for durability, couldn't sustain that kind of abuse without serious modifications. But the real genius of the 327 in pickup applications wasn't just straight-line performance. It was the complete transformation of the driving experience. The engine's smoothness was remarkable for a pushrod V8. Chevrolet had perfected what they called dynamic balance, careful attention to reciprocating masses that eliminated vibration. At idle, you could balance a quarter on the air. Cleaner. At redline, it felt turbine smooth. The sound was pure American muscle, not the metallic shriek of Italian V12s or the mechanical thrash of German flat 6s. The 327 produced a deep, throaty rumble that turned into a hard-edged roar at full throttle. With the optional dual exhaust, the sound was intoxicating. European automotive journalists who experienced these trucks for the first time were universally shocked. Britain's Motor magazine got their hands on a 327-powered C10 in 1968 for a comparison test. Their conclusion was devastating for European manufacturers. The Chevrolet pickup offers performance matching our finest sports saloons at a fraction of the cost, with the added utility of load-carrying capability. Its crude construction is offset by sheer mechanical robustness and surprising refinement. European manufacturers should be concerned. The French were even more impressed. L'Automobile magazine's test driver wrote, "This agricultural vehicle accelerates like a Vega, cruises like a Citroën DS, and costs less than a Peugeot 404. It is an affront to everything we believe about automotive engineering, yet it works brilliantly." The German press was predictably analytical. Automotor and Sport performed their typical exhaustive testing. They measured everything: acceleration in each gear, braking distances, fuel consumption, noise levels. Their verdict: the 327 engine represents American engineering at its finest, simple, effective, and powerful. In the lightweight pickup chassis, it creates a vehicle of surprising capability. Sales told the real story. In 1967, the first full year of 327 availability in pickups, Chevrolet sold 42,019 C10s with the optional V8. By 1968, that number had grown to 67,234. The take rate for the 327 option was approaching 30% on short bed models. Buyers were willing to pay extra for serious performance. The aftermarket noticed too. Suddenly, speed shops that had focused on muscle cars were developing parts for pickups: headers, camshafts, intake manifolds, all designed to extract even more power from the 327. Edelbrock developed a special dual-quad manifold specifically for truck applications. Hooker headers created equal-length tubes that fit around the truck's frame rails. Mickey Thompson sold special tires sized for 15-inch truck wheels that could handle the power. Drag strips across America started seeing pickups in the staging lanes. The lightweight short bed models with the 327 and a 4-speed were running low 14-second quarter miles with basic modifications. Add slicks, headers, and a high-performance cam, and 13-second time slips were achievable. Some of the wildest builds were breaking into the 12s, faster than many purpose-built muscle cars. The 327 pickup phenomenon created a cultural shift. These weren't just work vehicles anymore. They were performance machines that happened to have a bed. Young buyers who couldn't afford a Camaro SS or Chevelle SS could get similar performance from a basic C10 with the right engine option. Insurance companies hadn't caught on yet. A 327 pickup cost far less to insure than a comparable muscle car. The racing success was remarkable. In 1968, a nearly stock 327 powered C10 won its class at the Winter Nationals Drag Racing Championships. The driver, Bill Jenkins, later said, "Everyone laughed when I rolled up to the staging lanes in a pickup. They stopped laughing when I ran a 13.9 at 102 miles per hour." NASCAR even took notice. The pickup truck racing series that would eventually become the NASCAR Truck Series can trace its roots to these 327 powered machines. Informal races at fairgrounds and dirt tracks proved that trucks could provide exciting competition. The combination of V8 power and rear-wheel drive with no weight over the axle made for spectacular racing. But perhaps the most significant impact was on automotive engineering philosophy. The 327 pickup proved that performance didn't require complexity. While European manufacturers added overhead cams, fuel injection, and exotic materials, Chevrolet showed that a simple push-rod V8 could deliver comparable or better performance at a fraction of the cost. The reliability advantage was undeniable. A 327 could go 100,000 miles between rebuilds with basic maintenance, oil changes every 3,000 miles, occasional valve adjustments, and it just kept running. Parts were available at any auto parts store in America. Any mechanic could work on it. Try finding parts for a Lancia Fulvia in Kansas City in 1968. The thermal efficiency was surprisingly good, too. Despite its large displacement and simple technology, the 327 could deliver 15 to 18 miles per gallon in highway cruising. Not impressive by modern standards, but comparable to much smaller European engines of the period. The difference was that the 327 made its fuel consumption worthwhile with massive power delivery. General Motors engineers had achieved something remarkable. They'd democratized performance. The same basic engine that powered Corvettes and Camaros to racing victories was available in a working man's pickup truck. The technology transfer was complete and uncompromised. This wasn't a detuned economy version, it was the real thing. The international implications were profound. European manufacturers had built their reputation on engineering sophistication and exclusivity. The 327 pickup challenged both assumptions. Here was an American work vehicle that could outperform Europe's finest grand tourers, using technology that was almost agricultural in its simplicity. It was a wake-up call that resonated through the industry. Ford responded with their own hot rod truck, the 390 V8 in the F100. Dodge countered with the 383, but neither had the same combination of lightweight and high revving power as the 327 C10. Chevrolet had accidentally created the perfect formula, just enough truck to be useful, just enough performance to be thrilling. The insurance industry finally caught on by 1970. Suddenly, 327 powered pickups were being rated the same as muscle cars. The party was over, at least officially. But the impact was permanent. The idea of the performance pickup was established. It would resurface in the 1990s with the 454 SS and Lightning, and continues today with Raptors and TRXs. The 327 itself was discontinued in 1969, replaced by the 350 that would become Chevrolet's most prolific engine. But for those few years, it had transformed the pickup truck from utilitarian tool to performance icon. It had embarrassed European sports cars, confused insurance actuaries, and delighted thousands of buyers who discovered that practical could also mean powerful. Looking back, the 327 pickup represented peak American automotive ingenuity, not in the sense of advanced technology or sophisticated engineering, but in delivering maximum performance per dollar. It was the embodiment of the American approach. Keep it simple, make it powerful, make it affordable, and make it last. The legacy lives on in every performance truck built today. When Ford builds a Raptor with 450 horsepower, they're following the template established by the 327 C10. When Ram stuffs a Hellcat engine into a TRX, they're chasing the same formula, massive power in a practical package. The only difference is that now it costs six figures instead of $2,700. Modern automotive journalists often wonder when trucks became performance vehicles. The answer is 1967, when Chevrolet decided to offer a 327 cubic inch small block in their half-ton pickups. It was a simple decision that changed everything. It proved that performance wasn't about complexity or sophistication. It was about giving people the power they wanted at a price they could afford. The 327-powered pickup was democracy in action. It was blue-collar performance that could humble blue-blood sports cars. It was American engineering at its most effective, not the most advanced, but the most successful. In an era when European manufacturers were creating increasingly complex and temperamental machines for the wealthy few, Chevrolet was putting genuine performance in the hands of farmers, contractors, and anyone else who needed a truck that could haul lumber on Friday and humiliate Triumphs on Saturday. Today, surviving 327-powered pickups from this era are highly collectible. A pristine 1968 C10 with the original L74 327 can command $50,000 or more at auction. That's more than many of the European sports cars they once embarrassed. It's a fitting vindication for what was once dismissed as just a work truck with a big engine. The lesson of the 327 pickup is timeless. Engineering excellence isn't always about complexity. Sometimes it's about understanding what people actually want and delivering it in the most effective way possible. Chevrolet understood that Americans wanted power, reliability, and affordability. The 327 delivered all three in a package that happened to have a pickup bed attached. Every time you see a modern performance truck, remember the 327 C10. It started the revolution. It proved that utility and performance weren't mutually exclusive. It showed that American engineering, for all its supposed crudeness, could deliver something European sophistication couldn't: accessible performance for the masses. That farmer's truck that disappeared from the stoplight in 1968? It wasn't an anomaly, it was the future. And it all started with 327 cubic inches of American small block that refused to apologize for what it was: simple, powerful, and absolutely perfect for its purpose. What's the fastest classic truck you've ever encountered? Did it surprise you? Let me know in the comments below. And if you enjoyed this deep dive into one of America's most unlikely performance vehicles, make sure to subscribe. We're just getting started exploring the machines that changed automotive history. Until next time, keep those engines running.